Hello everyone, and welcome back to the Introduction to Python course. In this video, we will be talking about Chapter 10, or Classes and Object-Oriented Programming. Now, up until this point, we've been doing what's been called procedural programming. We've been using procedural programming this entire time, and that is just us making functions, taking data, and passing this data that we have through these functions. Specifically, this procedural programming is what we've been doing so far. But now we'll be talking about what's called object-oriented programming. It's a different style of programming, has its advantages, has disadvantages of course as well, but does have a lot of advantages and it's important to understand it. Along with this, inside of object-oriented programming, there's something called classes. We'll talk about what those are. We'll talk about how to work with instances of classes, which are called objects. We'll talk about techniques for designing classes, as well as we'll cover some Chapter 11 material, including things like inheritance and polymorphism. We include this in this chapter as that actual Chapter 11 in the book is short and not long enough for its own actual section in the class. But it's important to understand both inheritance and polymorphism to make sure you get the most out of using classes and object-oriented design in Python. So like I said originally, this entire time you've been doing what's being called procedural programming. This is basically where we make a whole bunch of different functions, like the main function. If you've ever done a menu-driven one where we have to add, update, delete users, these are all procedures that we're going to be using in our program. Any data we have can use any function. There's no restrictions or anything. So that's what we've been doing so far. So that looks sort of like this. In this case, you have your main program. Your main program here will then call some set of functions. So let's say we have a menu-driven program. The function 1 might be your menu function. Function 2 might be to add users. Function 3 might be to update users. Maybe you have a function on the same level here, on the side over here, where it updates users. You have add, update, delete. You have all those functions. Now those functions might also call other functions. So maybe when you add a user, you call another function that actually adds a user, and then that function can call other functions as well. This is a procedure. It's a set of steps that a function needs to take. Now again, any data, anything in the main program can access any of these functions. There's no restrictions. What we're going to move on to now, though, is what's called object-oriented programming. So what we're going to do is we're going to make an object by combining data, variables, also known as attributes, and procedures or functions, which we'll now call methods. So again, you're going to take variables and functions. In this case, the variables are going to be called attributes, and the functions are going to be called methods. We're going to take those, we're going to push them together, and we're going to put them in a box. We're going to encapsulate them by combining them into a single object, and we're going to put them into what's called an object. The object will have, again, attributes and methods. So why do we do this? So we do this because by combining things into an object, we can actually hide data and we can restrict access to certain methods / functions, as well as certain attributes / data or variables. So we can restrict it to protect it from accidental outside corruption. We can also stop outside code from not actually understanding the internal structure and also restrict how things are changed. Moving on from there, objects allow us to reuse them just like we can reuse functions. We can use the same object in different programs as well. So how are objects going to actually work? So instead of having the procedural process, what we're going to do is we're going to have objects, and these objects are going to communicate with each other. We can communicate through the main function with objects, and they can communicate with each other through their methods. So for instance, if you have object 1 here, object 2, and object 3, they'll all have different little data attributes at the top here. That's their variables associated with each object. But then to actually mess with and interact with those data attributes, we will use what's called methods. These are the functions associated with each of these objects. By using these methods, we are preventing any kind of corruption of the actual variables / attributes in these objects, as well as also restricting how the attributes can be changed and interacted with. So for example here, let's imagine you have this, and let's imagine that you have a few different objects. So a good example of that would actually be a clock. Okay, so let's say you are one of these objects. So let's come back up here. You're object 1, you're a person. Object 2 might be a clock. Okay, so this clock object will have attributes specifically for the second the current seconds, the current minutes, the current hours, and a set alarm time. Public methods are the ones that we're going to use to interact with that object. Specifically, things like display time, and set alarm time are things that we as a person object can call to interact with the clock object. However, things that we can't do, but the clock needs to do, these are called private methods. They're used for the inner workings. So if a clock needs to increment the time, it'll call its increment time method. If a clock says, hey, it's the alarm time, we need to ring the alarm, it'll ring the alarm, it'll call the ring alarm method within its object. So for example, let's assume that we're back over here. We have our clock, it has the set time method down here, and us as a person, we may have a method called set clock time. This method on our end will call the method on the clock end to set the time of that clock. That's how that's going to work. We'll have a method on our side that says we need to set clock time. That's something us as a person can do. On the other end, we might have a clock that says set time. To use that, we will call the set clock or the set time. We'll use the clock object inside of our set clock time person method, which will then allow us to interact with that clock. This will all make more sense in a little bit as we go through examples, but just keep in mind, again, objects are going to interact with each other, both the main function and each other, the main function and other objects are going to interact with one another through their methods. They will not access the data attributes directly. That is unsafe and not a good programming practice. All right, so after we have our objects, we need to figure out, well, how are we going to build these objects? We're going to use what are called classes. Now, classes are just code that specify the data attributes and methods that a particular type of object will have. So imagine a blueprint of a house. Okay, these blueprints can be reused, and specifically when you build a house using a blueprint, you're creating an instance of that blueprint. You're creating a house. An instance is an object created from a class. That's what that is. So again, if we come down here, we'll see we have our blueprint. If we have this blueprint over here, you see that we have the same blueprint and we can use it for all 6 of these houses. So we create 1, then we can create 2 more, and then 3 more after that. We can create as many instances of a class as we want using a set of blueprints. Now, not every one of these houses are going to be the same. There can be many instances, but they might not be the same. So they don't have to be identical, and instead, we might have one house, if we're going back to the house example real quick, we might have one house that has 30% more square footage than the other one. Same floor plan, same everything, but the square footage might be different. What that means is they have the same class as a blueprint, but some of the actual attributes inside are different. So again, each instance will have the same set of attributes and methods, but they can have different values. So the attributes can have different values. You'll have the same methods to access those attributes. But for instance, in this example here with the insect, we might have a fly, we might have a bee. They're going to have the same data attributes, but one will be a type fly. That's the variable, type equals fly. And another one, type will equal bee. So we'll have type equals fly and type equals bee on the other end. So now that we understand that a class is a blueprint for an object, let's go ahead and see how we're actually going to do this in Python. Again, this will all make more sense as we start to roll through and do it in Python, because again, the best way to learn programming is through practice. So in Python, what we're going to do is we're going to create a class by defining it. So just like we did with functions before. So what we'll do is let's go ahead and make this insect example. So we're going to come over here and we'll say class insect. Note here that we're going to use an uppercase letter for our classes. In Python, it's good practice to use an uppercase letter to begin your class name. This is the only time that you'll see that we use uppercases. For everything else, we use lowercases, but to delineate when we're talking about a class, we use an uppercase. All right, so now that we have our class, this is all we have to do, class insect, like that. We'll come down here, we'll make our main as well. And then we can do the same thing as we've done before, if name equals main. Just like that. That's just how we'll start all of our Python programs. And now we have our class. So we have to ask ourselves, well, what goes in this class? In the class, we have our attributes and our methods. So methods in actual classes are like any other Python function, but require a self parameter. The self parameter is what's going to tell Python what class, or should I say, what object instance this method, this class method, is working on. So specifically, if we say we want to, let's say we talked about the clock example, let's say we want to set time. Well, if we have three clocks, three objects or three clock instances of a class like that, then which clock are we changing? The self will tell Python that we want to change the current object that we're looking at. The self, basically, imagine you're just taking your finger and pointing back to yourself. That is what self is doing. It's telling Python, hey, we're working on the one that called it. That's me. That's this class, this object that called it. So we'll talk about that here in a second. But again, before we do anything in a actual class or object instance in Python, we need to initialize it. So we have this init function right here. All right, so how this is going to work is we'll come over here and we'll say inside here, we tab in one to make sure we know we're part of the class. And we're going to do def underscore underscore init underscore underscore. Now you'll notice that if you're using PyCharm, it'll pop up. If it doesn't, you need to do parenthesis self, parenthesis, and then colon. It should look like that. That is what this function, this class method, is going to be called automatically when we create an instance of this class. Okay? So it's the first thing that's created. So if I come down here and I say something like I1 equals insect, like that, that's calling the class. When this I1 is, when this line is called, the first thing that's run is this initialization function right here. Okay? So what we want to do is we want to create this. So we have to ask ourselves, well, what kind of attributes would an insect have? So let's say it has something like type, like we saw before. It might have something like, let's say, size. And then maybe it has something like can, fly, some kind of Boolean like that. So when we're creating a class, we want to give it some initial parameters. So what we'll do is we'll put a comma here, and we'll say T for type, S for size, and F for fly. And we'll say self. Notice here I put self.type. This is saying that when we call this class, whichever object instance called, whatever object instance we're currently creating, that is the object, the attribute of that object that we want to change. We're going to say self.type equals T. That's the first variable we're going to put in. So here we might do something like fly, comma, size of that might be 0.5 centimeters, and can fly will be true. So this fly right here is going to be passed as an argument to this parameter T. We'll then take that string, fly, which is the type of insect, and we're going to store it in that object's type attribute. Okay? So we have type equals T. We'll do size, self.size equals S, and then we'll say self.canFly equals F. All right, once we've done this, when we call insect down here, it's going to take these arguments we give it. It's going to pass them to these parameters. Notice here again, we put self here, we do not put self down here. This is inferred from Python, so you do not need to pass self, and you won't pass self. Instead, you have to have it up here, but you'll have all of them down here. So these three will match with the three after self, just like that. All right, so now that we've done this, we have initialized our insect. So now, if I have these right here, I can do something like print I1 dot type, size, or can fly. Right now, these are not private. We'll fix this later, but if we could do print dot type, we run this, it'll say fly, just like that down here. So I'm going to go ahead and terminate that real quick. All right. So that means we can see that when we put this in there, we're going to, I1 right now is the object, and we're saying give us the object's type. The attribute of that object, which is type, which is the variable of that object, which is type. All right, so we've started actually creating this right here. So another example for you, as a side note, in case you're ever confused, is here's a coin example. So right here we have our initialization function again. We set the side up to equal to heads first. Then we have a couple other class methods as well, all right? So we have toss and we have get side up. Okay, we'll talk about these here in a second, but again, it's just we can call these from this class. This class has access to them, so when we make an object, the object will be able to call these and use them. All right, we'll keep going though. And in this case, we can create an instance that we saw, and we can use the method. So let's go ahead and finish up the insect example here. So we have our init right there. So then we can do something like def, and we can do something like eat, because an insect has to eat, just like that. Notice how when I put the parentheses, it automatically puts self here. If it doesn't, you need to put self here. All right, so let's ask ourselves the questions. What does an insect eat? Well, insects usually eat anything, but if we want to make this into some kind of simulation, maybe an insect would eat another insect. So what we'll do is we'll pass self, and then we're going to also pass a target insect, just like that. So it's one that's going to try to eat. So let's say we have two insects. We have I1, which is a fly, and we have I2, which is an insect, and we'll say that this one is, let's say, a hornet, just like that. This one's 2 centimeters long, and it can also fly, okay? And let's say we also have I3, and we'll say insect here. Let's say this one is equal to, let's say an ant, like that. And the ant is, let's say again, is probably like a 0.3, or actually, let's say it's 0.6. It's one of the bigger ants, but it can't fly, okay? So we have 3 insects, just like that. So what we're going to do is we're going to say we want one insect to pretend, or we'll just say simulate, trying to attack and eat another one. So what we're going to do is we have self, we have our initialization. All 3 of them are being initialized. I1, I2, and I3 are these ones right here. I1, I2, and I3 are our object instances. The class up here is our general blueprint. So then what I want to do is I want to say eat. So what I want to do is I want to say if, we're going to check size. So if an insect is bigger than the other one, it can eat the smaller one, okay? We'll say if self, which is the one that we're pointing, so we're saying this object that called this method, that's self. So if we have I1 call this method, self would be the fly insect. If I2 calls it, it would be the hornet. If I3 calls it, it would be the ant. Okay, so we're going to do self dot size. So we're going to say if the insect that called this method is greater than target insect dot, and we're going to say size as well, right? Just like that. Then we need to have another attribute here. We'll do self dot alive. We'll say that equal to true to begin with. If the other one's if the one we're looking at is bigger than the other one, then we're going to set target insect dot alive equal to false, just like that. So basically, the other one got eaten, and there you go. Otherwise, if we're actually smaller than it, then it would be self dot alive equals false, like that. So either we're bigger and we eat it, or we're smaller and we don't. Okay. So what does this look like? So if we come down here, we can do something like I1, the fly, is going to try to eat I3. We'll say I2. So we'll do dot eat. That's the method. So I1, the object here, is calling the eat method that it has from its blueprint, and we're going to pass it I2. So the fly is going to try to eat the hornet. Okay. If I come up here and I print I1 dot alive, and then I print it down here as well, we can see the difference in the changes that occur. So if I run this, you'll see that before we try to eat the hornet, the fly is alive. After trying to eat the hornet, the fly afterwards is not alive. What happens? The fly has a size of 0.5. That's self.size in this case. That is not greater than the target insect, which is I2 dot size, which is 2. So because the fly is smaller, it doesn't survive the actual encounter. Okay? So how can we go further? Well, we see we have this can fly option here. So if something can fly, well, maybe if it loses the encounter, it can fly away, right? So we'll say something along the lines of, if we're bigger than the other one, then the other one dies. Otherwise, we'll come down here, we'll say if we say self dot can fly and target insect dot can fly, but we want to say not fly. So we're saying if we can fly and the target insect cannot fly, then we're alive. So we'll say we don't do anything, so we'll pass. Otherwise, we'll say we don't live. Because if we can't fly, so if we can't fly, then we lose. If we can fly and they can't fly, then we live. Now we can simplify this logic a little bit by taking away the not and then putting this right here. So again, if we can fly and they can fly, well, they can catch us, so we don't live. If we can't fly, then we also lose. If they can't fly, then they also lose. So what we need to do is we need to actually add all those in there. So specifically what we're looking for, if not fly, so if we cannot fly, or we can fly, so we'll say self dot can fly, and the target can fly. We'll put some parentheses around here just to make it very simple. So if we can't fly, it doesn't matter what the other one, we die. Or if we can fly and they can fly, then we die. See what this says right here, multiple spaces, so we get rid of one of those there, clear that up. All right, so now we have this case. Now, if we're bigger than them, then we need to ask ourselves another question. We say, if we can fly, or actually what we have to really ask is, if we cannot fly, and the target insect can fly, then we don't actually kill it. So if we can't fly and they can fly, then we don't kill it. So it's a pass here. Otherwise, they do live. Now, again, we can simplify this logic, right? We can say if we can fly, so we'll change it around. We'll just go ahead and copy this logic here. And we'll say specifically, if we can fly, or actually we'll say specifically, if the target insect can fly, so if they cannot fly, or we can fly and they can fly, then they also lose. So specifically what we're saying is, if we're bigger than them and they can't fly, or we both can fly, they lose, because we can chase after them if we both can fly. If they can't fly, then, well, they can't go anywhere. If we're down here, then we say, if we can't fly, then we lose, because we can't get away. Or if we can fly and they can fly, then we also lose, because we can't, because they'll chase after us. All right, so we have our eat function here now. Now if I run this, we'll see a similar result, because I1 here, a fly, is trying to eat the hornet. Well, we're smaller, so we're down here. We can fly, but they can also fly, so they chase after us, and then we still lose. However, if I try to change this and I say, let's go after I3, the ant, we're smaller, but they can't fly. So we survive the encounter. We try to attack them, they fight back, and as a result, we fly away. So what we have here is an example of both an initialization method as well as a class method right here. This right here is showing you how you can actually work with multiple objects interacting with each other. So you have I1 interacting with I3. Now, there's other ways of going about this, but let's go ahead and move on from there. And again, this is how we're going to work around this. So if you see right here, we have a coin. We have our initial class definition. We initialize it right here. We make a toss class method. So if we toss it, we're going to have randomize. If the random result is a 0, we do heads. Otherwise, it's tails. So it's 50-50 shot. And then we have what's called a getter here. We'll talk more about them as we go. And that's a get side up. It returns that actual attribute to the actual user. This helps us control which ones they can and cannot access. All right, so let's go ahead down here. This is how you'd actually use it. We create the instance of the coin. We say get the side up. This said the side up on the coin is either heads or tails. Then we say I am tossing the coin. We toss it. And then we can check the side up again. It may become heads again, or it might be tails. All right, so let's go down to the checkpoint. If I asked you the question, what is an object? You might be able to say that it is an entity that contains data, which are also called attributes, and procedures, which are also called methods. Remember, data is your variables, and procedures are your functions. All right, if I ask you the question, what is encapsulation? You might be able to say it is the process of combining data and code into a single object. Remember, we encapsulate it by putting the variables and the methods into a nice little box that's called a class, which we can then use to create many instances of it. All right, why is an object's internal data usually hidden from the outside code? Remember, we want to protect it from accidental corruption and also restrict how it's altered. Remember, with objects and classes, we can restrict how it's altered. We can restrict how it's accessed as well. All right, what are public and private methods? Well, public methods are for external code. That's how the main function as well as other objects will interact with one another. And private methods are for inner workings. It's like the ticking time in a clock or the ringing alarm in a clock. All right, what is the purpose of the init method and when does it execute? Remember, the init method initializes objects, data, and attributes and assigns the self parameter when the instance is created. So when you call it, so if we come back over here, when we call this line right here, the init for insect class is called and it sets the type, size, can fly, and alive for that object. Okay? If I ask you the question, what is the purpose of the self parameter in a method? You might be able to say that it references the specific object the method is working on. So if I do I1.e, right here, I1, right here is self. That is what that is. I1 is self. I3, in this case, is the target insect. It's the other object. Self is whichever object calls the method. Okay, so when we create the insect, self here is I1 because I1 is equal to insect, which calls that class method, which is the initialization function. Okay, so let's go ahead and try another example. Let's try this together. Let's go ahead and design a dice rolling class that holds the following data. It's going to hold the number of sides, the number of dice, and the current sides up. And we want to make sure the class has a method to change the number of sides, change the number of dice, and toss the dice. After that, we're going to write a program that creates an object instance of this dice class, sets the number of sides to 20 and the number of dice to 3, and then calls the toss method and displays the results. All right, so let's go ahead and start with that. So what we're going to do is we're going to come over here to 1010. I already have a little bit of it set up, so go ahead and copy that down. And what we're going to do is we're going to import random. We'll need this for the actual randomization later. We start our class dice. We have our main here and our if name equals main. So we'll start with the actual class definition. So the first thing we're going to do after we start with class is we're going to do def underscore underscore init self, just like that. That's going to be our initialization function. In here, though, we need a few different attributes, or it's a few different parameters. We need also the sides of the dice and the number of dice as well. So we'll do dice like that. We're then going to do self dot num sides equals the sides they gave us, just like that. Then we're going to do self dot num dice equals the dice they gave us, just like that. All right, so now that we have that, we're going to come down here and we're going to do def set num sides. This is what's called a setter. We'll use these more as we go through, but all we're going to do is we're going to allow the user to change the number of sides using this method. We'll do that, and we're going to say if sides is greater than 1, self.numSides equals sides, just like that. We'll do the same thing for the number of dice. We'll do def set num dice. We'll put dice after it again. And we'll say if dice is greater than 0, so you need at least 1 dice, self.numDice equals dice, just like that. So that's going to give us the ability to create. So whenever we create an instance of dice, it's going to set the number of sides, the number of dice, and allows us to change them using these two methods. So we'll see that here in a second. Now we need a toss method right there. Now, if you notice, one thing that we've missed so far is we don't have the actual option here to for the current sides up. So we need to do that. So up here we'll do self.diceList equals an empty list. So we don't have any dice right now, we'll just leave it empty. When we go down to toss, we're going to do self.diceList equals empty. So we're going to empty out the dice list, whatever we have. We're going to say for I in range of self.numDice, just like that. So we're saying we're going to iterate through all the dice we have, and we're going to get a value. So we're going to say value equals random.randInt between 1, because remember dice start at 1, up to self.numSides. So ever how many sides. So we're going to get a random number between 1 and the number of sides of that dice. And then we're going to do self.dicelist.append the value we get. That's the dice, the face side, the side up on that. All right. So here's the thing though. When we initialize it, we do have dice. Imagine you take some dice out of a bag and you put them on the table. They're going to have some kind of random result right off the bat. So what we actually want to do is, instead of having dice list up here, we're going to do toss self.toss, just like that. What this is going to do is, when we initialize, it's going to set the number of sides, number of dice, and we're going to do toss, which will set the dice list like this right here. Now, what we can do is, if we want to, we can come up here and we can do self.dicelist equals an empty list like that. That's just a cleaner way of coding it, just because now you have no, no confusion about whether there's a dice list here or not. So we'll do that right there. Now, if we change the number of sides, we also need to update the dice list. So we'll do self.toss here as well. And then we need to update it if we do change the number of dice as well. So we'll do self.toss here as well. So basically, if we change, if we want to create, when we pull the dice out of the bag and put them on the table, then they're gonna have some result. If we change the number, the different type of dice that we're using by the number of sides, it'll change the faces as well. If we change the number of dice, it'll also change the faces as well. Okay. So now we're only missing one last thing, which is to figure out which faces are currently up. So we're going to do def get. We could say something like get sides up. It's going to be the get the sides up, and we're going to go ahead and return self.dicelist. All right. So now that we've done this, we can come down here and we can say my dice equals dice, and we said before in the problem we want a set of d20s with this number of sides 20 and the number of dice being 3. So size is 20, dice are 3, just like that. All right, so if we do that, and then we do something like, let's say print gets, we'll say my dice dot get sides up, we'll see the initial values of these dice. So we have 10, 9, and 15. Those are our dice. Those are the 3 sides up. If I run it again, we get something different and something different because of this random module that we have here. If I decide that I want to do my dice dot toss, and then I want to print it again, we'll see that the results change. We pick them up and we toss them down again. We get a different value each and every time, just like that. All right, so now let's say we wanted to do something like my dice dot set num dice. And let's say we want, instead of 3 d20s, we want 6. And if I print this again, I print my dice dot get side up, and we run that again, we'll see that now we have 6 d20s here instead. Notice how all the numbers here are ranging between 1 and 20. All right, so let's say we want to change the dice again. So we'll do my dice dot set num sides, and we want to change all these from d20s to d6s. We go ahead and print my dice again dot get sides up. You'll see that it changes again. Now they're between 1 and 6. Now again here, why do we put toss after every one? Because logically, this makes sense. As a programmer, this is the point in time where you're going to have to figure out what makes the most sense. In my mind, when I pull dice out of a bag, aka the init method, when I pull those out with that actual method, what I'm seeing is me taking dice out of a bag and putting them on the table. They will immediately have some kind of number. That's not an empty list. It will immediately have some kind of number. When I then decide to change out the dice that I'm using, which is the num sides, get set num sides here, I put the old dice away and I bring new dice out. When I do that, again, they have a random assortment on the table. Next, when I do set number dice, if I take dice away, there's 2 ways you can read this. You could say, well, I'm going to keep some of the ones that are already there. In my mind, I pick them all up, put away just the ones I don't want, and put the rest of them back on the table. That was another toss. Then if I do a toss, I can pick them up and just put them right back down, and that's toss as well. So as a programmer, you'll need to understand and learn what the best approach is for your problem and your actual program. Okay, so again, let's go through this real quick. We have your class. We have our initialization function. In here, we initialize all of the different variables for self. Remember, self is the object that called it. So when I come down here, the object is my dice. The class is dice. The object is my dice. The class is dice. So self is the my dice variable here, the my dice object. That one will have, just like how we had, let's say with the dictionary, we had key value pairs, it'll have multiple where you have my dice basically dot num sides, dot num dice, dot diceless, and then you have the different methods. So again, you need to have it set up like this, and then you'll have all the other different class methods you want the object to have access to. So my dice here is able to access toss, set num dice, and set num sides, just like that. It is also able to access the dot get sides up as well. So my dice can access any of those methods and has all of these attributes. Okay, so if that makes sense, what I want you guys to do is I want you guys to go ahead and try to design a class that holds the following personal data, specifically a person's name, address, age, and phone number. Then I want you to make sure the class has a method to change the name, address, age, and phone number of that person. I also want you to make sure you have methods that will print the name, address, age, and phone number of that person. After that, inside of your main function, I want you to write a program that creates 3 object instances of this class, and one instance should hold your information, and the other 2 should hold your family or friends' information. So go ahead, pause the video, give this a shot on your own, see if you get stuck anywhere. If you do, go ahead and unpause the video, and we're going to go over it together after you finish. All right, did you give that a shot on your own? So let's go over it. So the first thing we're going to want to do is we want to make our class. So we'll say class person. And in here, we need to ask ourselves, well, what kind of attributes will a person have? So we're going to start with our def in it, just like that. And in this case, we're looking at a person having a name, age, address, and phone number, just like that. Now in here, what we can do is, because we need to be able to set the actual name, age, address, and phone number, and get the name, age, address, and phone number, what we're going to do before we even do this is we're going to come down here, and we're going to build our getters and setters. Okay, you can do it either way. If you want to, you can make all your variables up here first, but I prefer to do it this way, where I'll do something like def, and I'll say set name, like that, pass a name in, just like that, and then it'll say if name dot is alpha, just like that, right? Then we can do self dot name equals the name you gave me. Make sure there's not two e's there. Now, an important thing to keep in mind is when you are using dot is alpha like this, keep in mind that this will not catch spaces. So if you want it to be able to catch spaces as well, you'll need to put in here name dot replace spaces with nothing, like that, and I'll remove all the spaces to make sure you have a valid name. All right, so after we have this, what we're going to do is we're going to go ahead and do this for the rest of them too. So we're going to do def, we're going to do set age, give the age that they gave us, like that. Then we'll say if age is greater than 0 and age is less than 200. We're then going to do self.age equals the age you gave me. Keep going. We'll do def set address. Now, not everything has to be this complicated. For instance, for address, you can sit there and validate all you want. I'm going to just go ahead and do self.address equals address. Just like that. Then it's going to be def, we'll say set phone. And then here we can do phone like that. And then we can say if phone dot is numeric and the length of phone equals 10, then we'll say self dot phone equals phone, just like that. All right, so now at this point, you're going to start noticing we have all these squigglies here that just says it's not been actually created or allocated. What we're going to do is we're going to come up here, and this time we're going to make it slightly different. We're going to put name equals a default value here. We're going to say age equals -1 here, and we're going to say phone equals a default empty string here. All right, so the reason why we're doing this is because in here, we're going to now do, instead of doing self.name, we're going to do self.setName to the name they provided us. Then we're going to do self.setAge to the age they provided us. Then we're going to do self, now here's the difference, we're going to do self.address equals address. Why do we do that? Because if you notice, name, age, and phone number have specific conditions on each one of these. We have that there, we have that there, and we have that there. By address, we don't really actually care for one. It is what it is. We just take whatever they give us. Because we want to verify this input and we want to validate this input that the user is giving us, we can put a default value for these three up here. And then we can do self dot the actual method name. So in this case, we'll do set phone for the last one, followed by the thing they gave us. And what will happen is, if they gave us a valid name, it'll come in here and we'll set that to the actual name. If not, this default value here will be used instead. Now notice here another thing. When you are outside of your class methods, you do not use the word self. You see that? Here's self here inside, here's self not here. This is because inside of here, you're in the general scope. When you go into methods, you need to have it tell which self it's talking about, which is the class's self. That's how you're going to tell. That's how it communicates back and forth. Okay? So again, if you're in the class directly, you don't need self. If you're in any of the methods working on the class, you do need to put self before the variable names. All right, so now you'll see that these squigglies here have gone away, just like that, that, and that, and that. So that's all good. So now what we need to do is we need to be able to use what's called getters, which will return the actual, all these attributes to us. So we'll do def get name. We don't need to pass anything because we're just trying to get something back. And we're going to go ahead and do return self.name. Then we're going to do def get age. And then we're going to return self.age. We'll do def get address. And then we'll go ahead and return self.address. And then we'll do def get phone. And then we'll go ahead and return self.phone, just like that. All right, so now that we have all of our getters, we have all of our setters, which we'll talk again more about in the future, our class is just about done. We're only missing one important aspect. We want to be able to also just print everything else. So we'll do def print info, like that. And then we'll go ahead and print out, we'll say name, that. We'll do dot format self.name. And we'll copy this for the other four. So we'll say name, we'll have age, we'll have address, and we'll have phone here as well. So it's our age, this is our address, and this is our phone number, just like that. All right, so our class at this point has default values at the top here. If you do not have default values, again, you just do them in the initialization function, just like this. So they have default values. Then we're going to go ahead and verify them. 1, 2, 3. Address does not need verification because we just take whatever they give us. Then we use these actual set functions here to make sure we get the correct values. And then we use get to return them back. And then we have our print info, which returns back print statements instead. All right, so now that we have this, what we're going to do is we're going to create a couple people. So we'll say P1 equals person. Now this creates an instance of the person class. In here, we're going to make the first name Bob. We'll have the age be 30. The address is 123 Way. And the phone number is going to be 843-123-4567. Then we'll do P2 equals person, like that. And the second person here is going to be Jim, who is 20, whose address is 456 Way, with a phone number of 843-098-7654, just like that. Now, if I come in here and I do P1, which is the object, P1, and I'm going to call the print info method, that's going to call this method with self being P1, And it's going to get p1.name, p1.age, p1.address, and p1.phone, just like that. If I do it again, if I do print p2.printinfo, like that, and I run either of these, you'll see we have our name, address, age, and phone for the first person object, and then we have the name, address, age, and phone for the second person object. All right, so again, this is how we're actually making our objects. Right now we have up here, we have our default values. If you do not have default values, put them in the initialization function like this. If you need to verify them at all, put a default value out here like this, and then use a setter function like these to actually set the value after checking it. Okay. Now that we have that, we can go ahead and move on. So again, we've talked a little bit about why we have these objects in these classes. But again, if you notice, we talked about data hiding, but we haven't really hidden anything yet. So what we're going to do from now on is we're going to use these double underscores again. You've seen them a whole bunch. And by using them, we make something private. So again, if we come back over here, we have all these setters and getters. You may be asking yourself, why do we have all of these? If we can just do, if I come down here and I do print p1 dot name, I can just do that. Why do I need those getters? Because if I do that, you have name right here. So the reason being is because by actually putting underscores before them, like this, like this, like this, and then we'll do it for address as well. Put underscores in front of all of them, and you will need to go back through and actually add them to everything just like this. Keep going through. And you'll see the reason here in a second. So what this is going to do is it's going to block the access to these variables from outside in terms of the immediate accessibility. So what that means is if I do all this and I come down here, I have p1 name. If I run that now, it's going to say, hey, it doesn't have an attribute name. If I do, okay, well maybe I should have changed it to underscore underscore, right? If I run that now, it says person object has no attribute underscore underscore name. What this means is it doesn't matter if we try to put underscores in front or not. If I do p1 dot, you'll see all of those variables in this actual context menu are gone. They are all completely gone. They're hidden behind the scenes. You can't get them. The only way I'm going to get the name now is if I do get name. If I run that now, it will return me back the name. So it completely locks it off. So if you don't want something to be accessible, you just don't have a getter. So if I don't want them to ever see the name, I can take that away like that, and they'll never be able to see the name in this actual user. Okay, so that's what these underscores do. It allows us to lock things off. All right, another thing we can do, and we'll see this later on in the actual lecture here, is we can actually store classes and other modules that end in .py and import them into the other thing. Again, don't worry about that right now, but we will see that coming up as well. All right. So let's imagine that we have a bank account class. Why would that data hiding be important? Because when we create the bank account class now we can actually hide the balance attribute of the bank account so that it's not accessible to everybody who has access to the system. So an example here would be, let's say we create a bank account and we have an initial balance. We set that to underscore underscore balance, which means it cannot be accessed from outside the class. And then we do deposit and withdrawal. So what this means is the only way you can access the underscore underscore balance object instance attribute is if you deposit money or withdraw. You can't just set it to any random value. So for instance, if you do amount and you do deposit, you can increase the balance by that amount. If you do withdrawal, you have to have at least that much. And then at that point, if you do have that much, it'll decrement it from your account. Otherwise, it'll say insufficient funds. So this prevents any kind of outside of corruption of the data, as well as any kind of erroneous behaviors of the program. All right, so another thing we can do is we have also the underscore underscore str method. Similar to the init method, this one is also a key method in Python. So the str method naturally displays the object's state. So what this looks like is if I come over here and I just do print p1, the object state looks like this right here. It tells you which function created the object itself, and the memory location in the system of that object. So with that being said, that's how str works. Now that doesn't really help us too much. So what we can do is we can redefine what str displays. So we're going to do this by coming up here to the top, and we're going to do def underscore underscore str self, just like that. And then instead we're going to have it return, and instead of having this print info down here, which we can keep it, it's not a big deal, but we can do more. So now we can return name, \n. We can have age, \n to make new line characters. We can have address, \n, and then we can have phone, \n. When we do dot format on that, we'll then do self dot name. We'll do self dot age. We'll do self dot address, and we'll do self dot phone, just like that. So that's going to return back. So what that means is now when I print P1, instead of giving this long string, it's now going to give me back this part right here. So let me go ahead and close these out, comment them out, just so we can actually fully see what's going on. We'll get rid of this one. So if I run print now just on the object itself, instead of making that string, it's going to print whatever is returned from the str function like this. The str method returns this. So if I wanted it all on one line, I can get rid of the \ns like this. I'll leave that last one there just for formatting purposes. If I run that now, it's going to look like that right there. So you have your name, Bob, age, 30, address, phone. So there you go. We've basically changed how the print function is going to work, because by calling an object with the print function, it's going to go find the underscore underscore str method and then use whatever that gives back. Now, if you don't write anything, it's going to give you back that long string of the object state. But for us, we actually want to be able to use that method. So let's go ahead and just put this in there, and it allows us to get a better formatted view of the object. Again, here's another example here. So for instance, with the bank account example, we can say instead we want to return, and instead of doing the state, we're going to say the account balance is whatever it was. All right. So again, with objects, one of the biggest things to keep in mind is that when you're working with objects, you have what's called instances. Okay. Instances belong to a specific class, but they all have their own set of attributes. So for example here, let's say we have 3 coins. We initialize them, again from the coin example, they all initialize to heads up first. Okay, it's not random, they all start with heads. Then after we toss the coins, coin 1 may have tails, but because coin 1 has tails, does not mean that coin 2 and coin 3 will also have tails. Instead, coin 1 will have its own version of side up, coin 2 will have another version of side up, and coin 3 will have yet another version of the side up attribute. Each one of these are distinct from the others. There is no overlap. An object is its own separate entity from a different object. Okay, so as we were saying earlier, we kept on using the words get and set. The reason being is because in programming, it is a very good practice to, whenever you're working with classes, to have methods called get and then whatever the attribute is, and set and then whatever the attribute is. This is because it makes it very easy for other programmers to understand what your code is trying to do. So in this class, what we're going to do a lot of the time is we'll have things over here where we have set name, set age, set address, set phone. And when you're doing your getters, they should be get name, get address, get age, and get phone. So you should use get and set when making these methods because it makes it very clear as to what they're doing. All right. So again, here you'll see we have get name, we have set name, we have get age, we have set age, and so on. Same exact approach. If you're ever confused, go back to the slides, come back to this video. Make sure you understand what accessors and mutators are, because this is what is going to be very critical when building these classes. All right, and lastly, like we saw earlier, we can also pass objects as arguments to other functions and methods. So for example, we come back to the insect example, we're passing i3, the object, to the eat method right here. So i3 is a variable, it's a parameter, and i3 is an argument to this parameter here, which is target insect. So you can do that with functions. You can do that with other objects methods as well. They're just, you can imagine that objects are another type of variable you can pass around. Okay. So if I asked you the question, how do you hide an attribute from code outside? You would put 2 underscores before the attribute's variable name. If I asked you, what is the purpose of the str method and how do you call it, you could say that it displays the object's state when you print the object or cast it to a string, and you call it by printing or casting. If I asked you what an accessor method is, you should be able to say it accesses the value and returns the value of a data attribute. And what's another name for accessor? It is a getter or a get method. Okay. What is a mutator? A mutator stores / changes a data attribute's value. Again, what's another name for a mutator? It's a setter. So you have your getters and your setters. If I said a program creates 10 instances of the coin class, how many ups ___ side up attributes exist in memory? Your answer should be there are 10, one for each instance of the coin class. Okay? All right, so let's go ahead and try this together. We're going to write a pet class named pet, so that's what the pet class is going to be called, that has the following data attributes. It's going to have a name, animal type, and age. It should have an initialization method that creates these attributes, and it should also have the following accessors and mutators. We'll have a setter and getter for name, a setter and getter for animal type, and a setter and getter for age. We're going to write a program that creates an instance of this and asks the user for the name, type, and age before storing in an object's attribute. All right, so let's go ahead and get started on this. So we'll be over here. Again, we start with our class, we start with our main, and the first thing that we're going to do in this case is we're going to start with some default values. Again, so we'll say __ name equals empty string. We'll also say __ animal type equals an empty string. Then we'll say __ age equals -1 just to show that it's not correct. And then we'll do def init, just like that. And again, we're going to be taking from the user the name, age, or we'll say, let's go in order here. We'll do name, animal type, and age, just like that. Here we're going to then do self. Now remember, before we do this, we actually want to make the setters for these. So we'll do def set name. And again, just like we did back here, we want to check to make sure it's an alphanumeric name. We can also grab age while we're here as well. So we'll grab both of these. And you'll see there's a lot of overlap and a lot of repeating in terms of the setters and getters as well. So we have our set name. We check to say, make sure it's alphanumeric, and we set a name. Age is the same way right here. Now again, for animals, sometimes animals do live longer, so we'll just be on the safe side and put 300 there instead. And then we also want to set animal type. So again, animal type will be very similar to name, so we'll copy this for set name, and we'll paste it right there. And we'll change this from set name to set animal type. We'll change this to animal type. Animal type, there we go. Then we'll say if animal type, when you replace I'll remove all the spaces, is alphabetic, which means it should be like it should be. Then we'll say animal type up here, self.animal type equals animal type. So now we have all of our setters. So now that we have that, we can come back up to our initialization function and we can do self.setName. We can do self.setAnimal type. And then we'll do self.setAge. Now in this case, you'll notice we always use setters in this case because we do not have any attributes that do not require validation. So all of them require validation, so all of them will have default values. Okay. Again, now we need our getters. So we'll do def get name, and we'll return self.name. Then we'll do def get animal type, and then we'll return self.animal type. And then we'll do def get age, and we'll return self.age, just like that. So we have our getters, we have our setters. Now the only thing we're missing now is if we want to actually display what the animal is, we'll come up here below init, and we'll do def str, and we can go ahead and return the name of the animal, \n, the type of animal, \n, and the age of the animal, another \n. We'll do .format, we'll do self.name, self.animal type, and self.age, just like that. We have all three. All right, so now we've built another successful class. So now let's go ahead and actually go down to main, and we can actually use this class now. So what we're going to do is we're going to first ask the user what the name of the pet is. So we're going to aim input, what is your pet's name? Then we're going to say, we're going to do age, but again, we need to validate age down here too. So we'll say while true. We'll then say try. We'll say age equals int of input. And we'll say how old is your pet? And then we can break if it's true. Otherwise, we can say print invalid age. Just like that. All right, so we have those. Then we can come down here, we can say animal type equals input. And we can say what type of animal is your pet? Just like that. Now that we have all the different variables we need, we can do P, which is your pet. We can say P1 equals pet of name that you gave, animal type you gave, and age you gave. And then again, we can come down here, we can print P1. All right, so if we run this now, we'll say, what is your pet's name? So we'll say, let's say it's Max. How old is your pet? We'll say maybe he's 3 years old, and it's a dog, just like that. So when I come down here and I print P1, it'll now print name Max type dog age 3, just like that. So now we're successfully using this pet class. Again, we have our default values here. We have our initialization function that uses the setters to make sure that the actual values coming in are correct. We have a str method here, or string method, which will return back a string that we want to print based on the object's attributes. Then we have our 3 setters, and we have our 3 getters down here. Okay, so this is again another successful class that we've written. So what I want you guys to do now is I want you guys to write a class, a car class named car, that has the following data attributes. We'll have a year, make, model, and speed. The car should have an init method that creates these attributes, and then it should have setters and getters for year, make, and model. But for speed, I don't want to have a setter or getter. I want you to be able to accelerate and brake it, like brake the actual car, like slow it down. That'll be your 2 setters for speed, and then you'll have a getter for speed as well. I want you to write a program that creates an instance of this class, accelerates 5 times, calls get speed, brakes 5 times, then calls get speed again. So go ahead, again, try this on your own, pause the video, try to practice it on your own, take some time, don't just give up immediately, look into it, think about it, try to understand it. And when you're ready to go back over it, go ahead and unpause the video. All right, did you give it a shot on your own? So let's go ahead and go over this. So I'll come over here, and we're going to have our car class again. And what we're going to do is we're going to start off with a few values. Again, we'll have our def init here. And what we're going to do is we're going to make a few default values here. We'll have underscore underscore year again. The year shouldn't be negative, so we'll start off with 0. We'll have a make. We'll have a model. We have those 3 default values. Okay. So then what we need again is we need our getters and setters. So we'll do def set year. Just like that. Now again, in this case, the year sounds very similar to like an age. So we'll grab this age one here. And we'll put that here. We'll get rid of this top part. And we'll say, specifically, if the year is greater than 0 and the year is less than, let's say, the year 3000, then we can do something like self.year equals the year you gave us, just like that. That's our setter for year. Now, when we do make and model, it sounds very similar to something like a name. So we'll grab the name one, and we'll paste that twice, once for make and once for model. And we'll set make, we'll set model. We'll change name here to make. We'll say if make.replace, there's no space, there's no numbers or anything in make. So if that doesn't sound right, we can always do is al num, or alphanumeric. And then if that's good, then we can say, actually, wait, the make should be alphabetic like that. The model might have numbers in it. So we'll do this. We'll do make like that. And then down here, we'll do model. If model dot replace is alnum, like that, then at that point, we can go ahead and change the model that we have to be that one there. We have all three of our setters. So what we're going to do is we're going to come in here and do self dot set year to the year that we're given. So again, we need to take in a year, a make, and a model from the user, just like that. And then we'll have self dot set make from the make that they gave us, self dot set model from the model they gave us. Now again, we need to make the speed one. So we'll do self dot speed equals 0. It's going to start off at rest, just like that. All right, so again, we want to make sure we have a string function as well, just like that. And we'll go ahead and return the year of the vehicle, the make. We'll do it all in one line this time. We'll do make, we'll do model, and then we'll do speed, just like that. And then what we'll do is we'll do dot format. Okay, so we'll do dot format, and we'll do self dot year, self dot make, we'll do self dot model, and then we'll do self dot speed, just like that. So now we have our string function. So when we print up the car, that's what we're going to get. All right, so now again, we need to have getters for these as well. So let's go ahead and do those first. Do def get year, and we'll return self dot year. And then we can copy this for the other two. Actually, remember, we have one for speed too. So we'll say get year, get make, get model, and then we'll do get speed. Okay, so we have all of our getters just like that. Now we need two more setters. Remember, we need one for accelerate and one for brake for speed. So we'll do def accelerate. We don't need anything, remember, because over here it says we're going to go up and down by 5. Right here it says adds 5 to the speed. So we don't need a value that they're accelerating. We're just going to say accelerate, and we'll say self dot speed plus equals 5. Then we do brake. We'll do def brake, not the other brake like that, but it's brake like a car brake. And then we're going to say self dot speed minus equals 5. Now the problem with this is you need to check to make sure it hasn't gone below 0. So we'll say if self dot speed is less than 0, then we're going to say self dot speed equals 0. All right, so we have all of our actual functionality now. So what we're going to do is we're going to come down here. We'll put that back there, make that look nice. And then we'll come down here. We'll say my car equals car. The year is going to be a 2018. We have a make, which is a Toyota. And then the model is, let's say, a RAV4. And then that's what we have right there. Remember, the speed starts at 0. We print C now. We run that. We'll say print, instead of not C, we'll print my car. I'll run that now. You'll see it gives me the year, make, model, and a speed of 0. If I then say for I in range of 5, we do my car dot accelerate, and then I do something I say like print my car dot get speed. We'll see that it's now at 25. That's the speed. So if I print my car below that as well, you'll see it is now 25. If I repeat this process but the other way around, so I say for I in range of, let's say 5, I do my car dot brake, and then I do these exact same commands again, you'll see that is going to be back down to 0, just like that. Now, if I change this number from 5 to, let's say, 6, it'll still be 0, because, again, I check right here to see if I'm less than 0, then it's just equal to 0. Okay, so again, now we have another class that we've built. This one, again, has initialization. We have a few default values up here. We have a non-default value, but one we declare in the actual initialization. We have our string method. We have multiple setters. We have 2 different setters for the same attribute. You can do that. We also have multiple. We have one getter also for each of the different attributes as well. Okay, so what we'll do now is we'll come over here and let's go ahead and actually talk about how we can design these classes. So obviously up until this point, we've talked about sort of giving you all the different pieces you already need to design a class, but let's think about how you would do it in a real world scenario. So in a real world scenario, you have what's called a UML diagram. These are standard diagrams for graphically depicting object-oriented systems. So for instance, if we're looking at that coin we did before, the top is the name of the class, the second box set is the attributes, and the third is going to be your actual methods. Okay, so let's look at this. So let's assume that we want to find classes in a problem. So when we're developing object-oriented programs, the first thing we have to do is try to identify the classes. So these are typically just real-world objects, and there's a few different techniques for getting them. The first thing we want to do is we want to get a written description of the problem domain. Then after that, we want to identify all the nouns, that's the person, places, or things, in the description, each of which at that moment are actual potential classes that we could build. Then we want to refine that list down to include only classes that are relevant to the problem. So for instance, let's go here. So let's go ahead and let's imagine the first thing we're going to do is get a written description of the problem domain. Now you might be the one to write this, or whoever you're writing this program for might write this, but it should include any and all physical objects, the roles of people, the results of a business event, and record keeping items. So let's imagine we have this. So we have a problem domain here. So we have Joe's Automotive Shop. So Joe's Automotive Shop services foreign cars and specializes in servicing cars made by Mercedes, Porsche, and BMW. When a customer brings a car to the shop, the manager gets the customer's name, address, and telephone number. The manager then determines the make, model, and year of the car and gives a customer a service quote. The service quote shows the estimated part charges, estimated labor charges, sales tax, and total estimates. So this is basically your problem domain, right? So the first thing we want to do is we want to gather all those nouns, right? So we want to do that. We want to identify those nouns, each of which could be a potential class. So if we're going to pull those out, this is what we find. So all these highlighted pieces here are the different nouns we found. So we have the shop itself, we have foreign cars, Mercedes, Porsche, BMW, customer, car, shop, cars, manager. Again, there might be overlap, but that's okay. We'll deal with that in a second. But these are all the different nouns in this problem. Now, all of these are potential classes. It does not mean they will become classes. Okay, so once we have that, we can then refine that list down. So we're going to remove nouns that mean the same thing. We're going to remove nouns that represent items that the program doesn't need to be concerned with. We're going to remove nouns that represent objects, not classes. So objects, remember, are instances of classes. So if there's multiple things that refer back to the same thing, we can remove those. And then we're going to remove nouns that represent simple values that can be assigned to a variable. So the first thing we're going to do is we're going to remove the things that mean the same thing. So car and cars are the same thing. Foreign car, car, and cars are all the same thing. And Joe's Automotive Shop is the same thing as shop. So we'll remove all those red ones. Then we're going to remove the ones that we don't need to solve the problem. So we're going to remove manager from the problem since problem doesn't store information on the manager. And we're going to remove shop since we work with individual quotes and the single shop. So since there's not multiple shops, we don't need to have a shop class. Now, if we wanted to expand this to multiple shops, then sure, we might do that. All right. Then we're going to remove nouns that might represent objects. So we're going to remove BMW, Mercedes, and Porsche because they're all instances of a car class. That means they identify objects, not classes. Okay. All right. Next, we're going to go ahead and remove nouns that might represent the simple values that can be assigned to a variable. So for instance, address, estimated labor charge, estimated part charge, make, model, name. All of these are attributes that will be inside of a class. So you remove all those out, and we're almost stuck with only 3 classes left. We have a car, a customer, and a service quote. Okay? So after we've done that, we can then identify what responsibilities a class may have. So as to do this, we had to figure out what the class is responsible for knowing, as well as identify the actions that the class is responsible for doing. Remember, knowing is your attributes, doing is your methods. To find out what a class is actually responsible for, we need to look at the problem domain. So in this case, what we're going to find out is that a car, all those last things we removed. So in this last part right here, we removed all these other pieces. We're going to put them back in as data attributes. So for instance, for the car, we're going to have make, model, year. We moved those in that last step, but we're going to put them in as attributes. Then we're going to have things like set/get, setters and getters for make, model, and year. So that's our car class. Then we're going to have things like our customer class, where we have, let's say, name, address, telephone number. And we're going to do an initialization function with setters and getters for name, address, and telephone number for the customers. Then we're going to have a service quote class with an estimated parts charge, labor charge, sales tax, and total charge. And that's going to have setters and getters for the estimated part charge, labor charge, sales tax, and total charge as well. Now we have 3 classes for this problem, all of which have their individual responsibilities and things they need to know. The UML diagram for this one at the end here would look something like this. So again, you have your attributes at the very top. Remember, the 2 underscores means that it is a private attribute. And then you have your actual class methods down below. All right, so that's how in a real world example you would actually go about creating one of these classes based on a real world problem scenario. So in this case here, we say the typical UML diagram for a class has 3 sections. What are they? If I asked you that, you should know that the top part is the name of the class, the middle is the data attribute, and the lower is the class methods. If I asked you what does it mean for what is a problem domain, you should know that it is a set of real-world objects, parties, and major events related to a problem. If I asked you who should write a description of the problem domain, you should be able to say that it's written by either you or an expert in the problem domain. If I asked you how do you identify the potential classes in the problem domain, you should be able to say that you identify all the nouns of the description as each of these are potential classes. If I asked you what does it mean, what are a class's responsibilities, you should be able to tell me that they're the things that it's responsible for knowing and what it's responsible doing. Lastly, if I asked you what 2 questions should you ask to determine a class's responsibilities, you should be able to say what the class, what must the class do and what must the class know. So it goes along with the responsibilities. All right, so let's go ahead and try this one. So again, this one we're going back to actually building it. Your local bank needs an internal system to hold pertinent information to its employees. The system should store the employee's name, ID, department, and job title. The manager of the system should be able to update and display all information within the system. We'll go ahead and write a class that solves the aforementioned problem, then write a program that creates 3 instances of the class and displays the information found within these classes. So in this case in particular, what we're looking at here is we need to figure out what kind of class we need to make. Now, if we look through this, we can sit there, we can actually go through it, but one of the biggest things that stands out in this case, because it's a simpler problem than the other one, is that it pertains to its employees. So again, when we go through the nouns, local bank, we're only at 1 bank, so we don't need that. Internal system, that's what this is going to be, so we don't need that either. Employee is going to be a huge thing in this case, so that'll be probably one of the classes we do. It should store the employee's name, ID, department, and job title. All of those are attributes. The manager of the system should be able to update and display all of the information within the system, but because we don't have multiple managers, again, we don't need that either. So the only class we actually need to make in this is an employee class that includes a name, ID, department, and job title. So let's go ahead and work on that. So we'll come over here, and we have our class, we have our main, and we have our name. So what we're going to do is the first thing we're going to do is we're going to create a few placeholders. So we'll have name, we'll have ID for the employee ID. We'll actually make that, yep, we'll keep that like that. We'll have our department like this. And then we're going to have our job title as well. Okay, so that's our default values. Then we're going to do our def init like that. And we're going to need to get from the user the name, ID, department, and job title for the employee. After this, we're going to do something with the actual getters and setters. We'll do def set name, but again, set name, we've been doing this repeatedly now, so we're going to come back here. We'll hit set name here. That's going to be the exact same again. We have our set name. Don't want that there. Come down here. Then we want to do set ID. ID again sounds very similar to something like age. So we'll grab that. So we'll say instead of set age, we're just say set ID. We'll say if ID is greater than 0, and let's say the ID maximum is 1,000. We'll say ID is equal to ID here, that. Then we have our set department. Again, it's text, so we'll keep the same as set name here. And we'll also have the job title, which is the same as well. So we'll say set department. So we'll change this to department here, department there, put a couple underscores in front of it, and we're good. Then we'll change this one to job title. We'll say set job title, like that. We'll do job title here, and we'll also do job title there. All right, so now we have all of our setters for those. Now we need our getters. So again, with those, we can just use get name here again. We'll copy that. Again, it's going to be the exact same over and over again. So we'll do get name, we'll get ID, we'll get department, and then we're also going to go ahead and get job title as well. Just like that. So we have our getters and setters now. Now again, remember, we need to go back to the initialization function and actually set them. So we'll do set self dot set name with name passed in. We'll do self dot set ID with ID passed in. We'll do self dot set department with department passed in. And then we'll do self dot set job title with job title passed in. So that way we can reuse the actual verification on these actual setters. Then we'll do def str, just like that, and we'll return back the name, and we can actually grab this from over here as well. We'll grab this here, and we'll return back name, ID, department, and then we'll also return back the title as well. Like that, and we'll have name, change this to ID, we'll change this to department, and we'll do self dot job title at the end there, just like that. All right, so now that we have that, we have our actual class built. That's all we had to do for this. Again, it's not super complicated. And what we're going to do now is we're going to do we'll say E1 for employee 1 equals employee. We'll say the first employee's name is J with the ID of 1, and he's in marketing. And let's say he's a manager. Just like that. Then we'll say E2 equals employee, and their name is, let's say, Julie. And that's a 2. And they're also in marketing. And let's say in this case, they're a social media lead. And then we'll have E3, and then we'll say equals employee. And this one's name is going to be Anna with an ID of 3. And then she will be in finances with a role of manager. And then if we go ahead and print each one of these, E1, print E2, and print E3, we can see that we will get each of these out, just like that. Okay, so now that we have our actual employee role here, what we're going to do is I want you guys to, assuming that you've created this, I want you to create a program that stores employee objects in a dictionary, uses the employee ID as the key, and then creates a menu that will look up employees, add new employees, change existing ones, delete, and quit the program. So it's just a menu-driven program like we've done before. When the program ends, it should pickle the dictionary and save it to a file. Each time the program starts, it should try to load the pickled dictionary from the file. If the file does not exist, the program should start with an empty dictionary. Okay, so I want you guys to go ahead and pause this video, try this on your own, and then see how far you get. After you get back, we'll go over everything else, and we'll move on from there. All right, were you able to give it a shot on your own? So let's go over this. So what we're going to do, and there's a couple ways you can do this. You can either copy this entire class into a new file, or you can come to the very top and we're going to import 10.4. So that right there, if you notice I changed the name to just text, it's a lot easier to import, and it's a lot better and to import just text in a Python file like that. So we're importing that Python file in. So now we have access to the Python file, or I'm sorry, the employee class over here. Now I already started this a little bit, so I have my menu, I have lookup, add, update, and delete methods. So what we're going to do is we're going to go ahead and start by actually working on the add method. It's usually a good one to start with. And what we're going to do first, though, is we're going to come down to main. And let's go ahead and actually start there actually instead. So we'll do employees right here equal curly braces. That's our dictionary. And we'll say while true, we're going to say menu. We'll call our menu. Then we're going to say choice equals input. And we'll say type here. So remember, the menu up here is going to ask us which one they want to do. And we'll just say, hey, type your prompt here. We'll then do .upper. And then we'll do .strip on it just to make sure it's sanitized. And then we're going to say if choice equals 1. Then we're going to look up employees. Elif choice equals 2. Then we're going to employees equals add employees, like that. Elif choice equals 3. We're going to then do employees equals update employees. That's what we're going to call the update function. Elif choice equals 4. We're then going to do employees equals delete employees. And then else, or should I say elif choice equals q. We'll then go ahead and break. All right, we'll add the pickling here in a second, but again, this is the starting point. So now that we have that, again, our class is already done. So what we need to do now is we'll go up here and we'll start with add. So with add, we're going to do name equals input. We'll say employee name, just like that. We'll make sure we don't have an extra E there. There we go. We'll get the input there. Then we'll say while true, try. We'll say ID equals int of input. And we'll say employee ID, like that. And then we'll do accept, like that. And then down here, we'll print something along the lines of invalid ID. So we'll do print invalid ID chosen, like that. And then over here, we can do break as well, just like that. All right, so that's how we're going to actually do our ID. We're going to come down here, and we're going to go ahead and do the other ones that we need as well, which is going to be the department and the title as well. So we'll do DEPT equals input, employee department, and then we'll have title equals input, employee job title. That. All right, so once we have that, we can then do E equals employee. But notice here, we don't have access to employee directly. We need to use our actual import. So we'll do 10.4 dot employee, like that. And then we'll give it the name, the ID, the department, and the title, just like that. Now that we have that, what we're going to do is we're going to do employee of the string version of that ID equals E. So we basically create our employee here, and then we link it to our actual dictionary here. After that, we want to make sure we save all the actual changes to that dictionary, so we're going to return employees, like that, and our add function is done. Now that our add function is done, we're going to go ahead up here to lookup, and we're going to do ID equals input. And we're going to say, please enter the ID of the employee you are looking for, like that. And we'll do try, and we'll say emp equals employees of ID. And then we can go ahead and print emp, and we say accept. We'll go ahead and print employee ID not found, like that. All right, so now we have our lookup and we have our add. We have our menu. So when we want to do update, we're going to go ahead and take the exact same code as add, because they're very, very similar. And what we're going to do is we're going to paste that in there. And we're going to ask them specifically, instead of name, we're going to ask them the ID. So we're going to come up here and we're going to say, please enter the ID of the employee you are updating. Just like that. So then we're going to come down here, we'll do try. And we're going to do EMP equals employees of ID. I'll print the existing employee like that. And then after we've done that, we can go ahead and take all of this code that we had originally and tab it in one. And we'll say, okay, so this is the employee you've had. Give me the new employee's name. We don't update the ID because that doesn't change. We have the new employee, so we can say something like new employee name. We'll say new employee department, new employee job title. And then we're going to create another employee based on that. So we have name, ID that we have here, but we do need to cast this to an int. It's a string right now. We have all of those. And then we're going to say that employee equals that. We'll say accept. And then we'll print something along the lines of employee ID not found. And then at the very end, once we're done, we'll go ahead and return back the employees we have with whatever changes we made. So that's how we're just going to go ahead and update. So we have our lookup right here. We have add right here. We have update. And now we need delete. So delete is going to be very similar to the lookup here. We're going to grab that. I'm going to say, and enter the ID of the employee you're looking or you're deleting. Like that. And then we're going to say, try to delete. So we'll do del employee like that. And maybe below it, we can even put something like print employee deleted, something like that. And if it's not, we can say employee not found. And again, we want to go ahead and return employees just to ensure all the changes are actually being moved over. All right, so now that we have this done, we're finished. The only thing we're missing now is we need to do try, and we need to pickle it. So what we're going to do is we're going to do fp equals open, and we'll say employees.dat. We're going to read binary here, and then we're going to go ahead and do pickle dot, we'll say employees equals pickle dot load fp. So we're going to load from that file. Now to do this, we need to import pickle at the top. We'll import pickle. And then we're going to say pickle.load this, except if it doesn't work, we'll say print starting with new dictionary, like that. So we're going to try to open it and load it. If it doesn't work, we just go with the empty one that we start with at the top up here. All right, after we finish, we can do the same thing. We're going to come down here and we're going to do fp equals open. We'll say employees dot dat, and in this case, we're going to write binary. And then we're going to do pickle dot dump the object we want, which is employees, comma, the file we want, which will be fp, just like that. So now every time we start this up, we're going to check for that file. If it does exist, we use it. Otherwise, we don't, and we keep with an empty dictionary. So let's go ahead and run this. And remember, by the way, too, a little side note here, so make sure you do fp.close each time. So let's do that real quick. It's the only line we usually miss. Then we'll go ahead and run. We'll go ahead and stop and rerun. Okay, so it says starting with new dictionary because we don't have anything to begin with. And we're going to say we add an employee. So we'll say Dakota, ID is 1, department is IT, and we have a manager, just like that. Okay, now if I hit Q, I have an employees.dat file now. If I run this again, we're going to go ahead here. It does not say starting with new one, so if I type 1 again, I type 1, my information is now here. It's been saved and been brought back. If I do 2 to add another employee, let's say we add Anna, ID would be 2, the department ID would be, let's say, finances, and the job title is manager, say something like that. Then if I look up 2, we see that information. If I look up 1, we see my information. If I do Q, it quits. When I run it again, both of those will still be active. If I look up 1, my information is there. If I look up 2, her information is still there. If I change information of, let's say, mine to be my first name, then we say information, and then the manager is lead. And I look it up again. You'll see that that information's changed now. If I delete myself, and it's been deleted, if I type Q, and then I come back in here, run it again. Now we'll see if I look up 1, doesn't exist, but if I look up 2, it still exists. Okay, so at this point, we've now built a menu-based program that works around a class in Python. Okay, so that is a huge step in terms of classes in Python, and now you understand fully how you can actually work with Python classes like this to actually make what you need to make full use of these classes. All right, so moving on now, that's the end of chapter 10 at this point. We're now going to go ahead and move down into the chapter 11 material here. Again, this is not required for what we're doing, but it is very, very important that you understand it so that you can get the full use out of your classes as well. Okay, so what we're going to do is we're going to talk about what's called inheritance, right? Inheritance is a relationship. So you have subclasses and superclasses. So specifically, if you think about animals, you have an animal. A dog is a animal, which means the dog would be the subclass and animal would be the superclass. If we're talking about dogs, we say a poodle is a dog. A pug is a dog. They both are dogs, which means they both inherit from a superclass, which is dog, and they are two different subclasses of that. Now, it's important to understand, and we'll talk about this more here in a second, but a subclass inherits all of the superclass attributes and methods. So if a dog has, let's say in the actual dog superclass, it has something like, let's say it has height and weight. When we do a poodle, then that poodle will still have height and weight from the superclass, but it can have other attributes that are different from, let's say, a pug. Okay, so that'll make sense here in a second. So let's look at this here. Let's say we have a vehicle. So vehicles will always have, any vehicle, doesn't matter what kind, will have make, model, mileage, and price. If we have a car might also have attributes for the doors and the number of passengers it can have. If we have a truck, well, a truck might have the number of wheels. We always know that a car will have 4, but a truck might have, let's say, 6, 8, 16, 18 wheels, whatever it is. It also will have a load capacity, a weight, and a tow capacity. These are things that a truck has, but a car does not. Now, a truck and a car both still have a make, model, mileage, and price, but a truck has some things that a car just doesn't have. Now, if we go on a motorcycle is a vehicle too, but instead of it's more based on speed and maneuverability. So things like max speed, engine CC, nitrous, sidecar, these are all things that a motorcycle would have that a car or truck probably just wouldn't. Right? So basically, let's say a car here, a car will have its door attribute and its passengers, but it will also have make, model, mileage, and price. A motorcycle will have max speed, engine CC, nitro, and sidecar, as well as make, model, mileage, and price. However, a motorcycle will not have attributes such as number of wheels, load capacity, doors, passengers, any of that, because that's not what because the motorcycle is not inheriting from the truck or car, it's inheriting from the vehicle class. So that's in terms of the actual attributes. In terms of methods, you'll see here we have our getters and setters on all of them, same exact thing, but again, it's going to inherit both of them. So a motorcycle can say get make, get model. It cannot say get doors, get wheels, because a motorcycle does not inherit from a truck or car. All right. So the biggest thing here, though, is to create a superclass, a subclass from that, you need to create the superclass attributes, methods, getters, and setters. So you create your superclass first. Then you pass your superclass as an input to your subclass. This includes, then you need to include the superclass parameter in the subclass init function. So you create the superclass in the subclass. We'll look at this here in a second. And then you want to call the superclass init function from the subclass init. And then you want to finish creating the subclass from that point forward. Note here, do not create getters and setters for superclass attributes in the subclass. They're already inherited. So let's look at an example here. So let's say we have a vehicle. We have our vehicle. This is our superclass. We have just a general class, right? So we have our init, we have set make, get make. We have all of them for model, price, mileage, and so on. After we have the superclass made, we'll then go to our subclass. Notice here, we have vehicle in the parentheses following the subclass name, okay? Then we have our init. Now we pass everything we need in here to make both the vehicle and the truck. So you'll see we have make, model, price, mileage, wheels, load, weight, and tow. After that, we're then going to call the superclass init function inside of the subclass init function. So we call that first. We say vehicle.init, and we bring make, model, price, and mileage. Then we're going to create the rest of the subclass, so wheels, load capacity, weight, tow capacity. Then we create the getters and setters for all the other subclass attributes. Remember, these superclass getters and setters are inherited when you do inheritance. All right, so that's inheritance there. Now, polymorphism allows subclasses to have methods that override superclass methods of the same name. So this is important to understand because maybe as a subclass, you might want to do something slightly different than the superclass did. Well, that's perfectly fine, and you can do that. So what's going to happen is it gives the program the ability to actually correct methods depending on what it needs to do. So for instance here, if we have a mammal, let's say a mammal has an init, show species, and make sound. So we just default to GER, and it says I am whatever species I am. If we want to change it, let's say a dog. So a dog is a mammal, and we say mammal.init. So now it can say I'm a dog, but a dog doesn't GER. Well, it can, but more likely we say bark bark. Okay, so that's going to change the make sound method from the superclass, and instead it's going to use the bark bark instead. Same thing with a cat. A cat's going to meow, and instead it's going to say I'm a cat still, but it's going to go meow instead of GER or bark bark. Okay. All right. So now, how do you tell if an object is an instance of another one? What we can do is we can use the .isInstance function here. Okay. So that prevents errors that occur when trying to access invalid attributes or methods. So if you want to say, oh, I don't know if a cat or a dog or inherit from a mammal, well, you can say, hey, is a cat or dog an instance of, that's the cat right there, is instance. So basically we would do something like is instant, parenthesis, dog, or your dog object, comma, mammal. And then it'll return true if it inherits from that class, or it is that class, and false otherwise. So an example here, we have a dog, cat, and a tiger. So and then we have not mammal equals not mammal. That's a string object right here. So we say if is instance dog, which is our object, comma mammal, which is our actual superclass, then we can say dog makes sound. So because this is true, it'll make the actual bark bark sound that a dog makes. However, if we say take that and we put in a string here, we say is this string an instance of this class? It's not, so it says that is not a mammal. Okay. All right. So now that you understand that, that's how we're going to extend our classes out. So if I ask you the question, look at the following class definitions here. We have class vegetable, we have our init, we have our self, our veggie type, we have a message, I'm a vegetable. If I have potato and a potato inherits from a vegetable, then we can say vegetable self potato. So it'll say instead of doing the veg type will still say I'm a vegetable, but the veg type will now be potato. And instead of doing message I'm a vegetable, it's going to now say I'm a potato. All right, so given these class definitions, what will the following display? If I do v equals vegetable, veggie, p equals potato, v.message will say what? I'm a vegetable. P.message will say what? I'm a potato. Okay, so notice here that they are different because P, the potato one, is overwriting, and it's polymorphic. It's using polymorphism to overwrite the message from the superclass with its own. All right, so let's go ahead and try this. So we only have two more here, so let's go ahead and try this. Let's finish strong. And we're going to write an employee class that keeps data attributes for the name and number of an employee. Then we're going to go ahead and create a production worker class that is a subclass of the employee class. And this class should keep data attributes for the shift number and hourly pay. So let's go ahead and start. So the first thing we're going to do is we're going to create an employee class and a production worker class that extends the employee class. So let's start with the employee class. And what we're going to do is we're going to start with name. And then we're also going to start with EMP number, the employee number. We're going to make our init. So we're going to do def init, just like that. And we'll say self.set name. We need to have, we need to have that actual setter first, but we'll go ahead and just put this here for now. And then we'll do self dot set EMP number. That'll be from the EMP number they give us. Now we need to put those up here. So it's name here, and EMP number here. Now we still need to make those setters, so we'll come down here and we'll do def set name, but again, you don't need to redo it. Don't reinvent the wheel. Just copy and paste it from somewhere else. We can copy both ID and set name. We're going to go ahead and paste those here, just like that. We have our name, we have our EMP number, but again, it's going to be called EMP number, not ID, so we'll change that out. And we'll do underscore underscore EMP, like that. And we'll say the numbers still are between 0 and 1000. All right, so that's our setters. So now we need to go do our getters real quick. So again, don't reinvent the wheel. Go get them from somewhere else if you already have them. Paste them down below. Make sure you change the function name. So instead of get ID, we're going to say set EMP number, get EMP number, and then there you go. So now we have our getters and setters set up for that first part. And then we need to do the string function as well. So we'll do def str. We'll return the name and then the actual employee number as well. We'll do .format. We'll do self dot underscore underscore name and self dot underscore underscore EMP number, just like that. All right, so our super class is finished. Everything in here will be used for a production worker as well. So now that we have that, we're going to come down to production worker. And in the actual problem, it says that it should have a, on top of what the employee has, it should have a shift number and hourly pay rate. So we're going to come down here, we'll do something like, we'll come down here, we'll do something like shift number equals 0 and hourly pay equals 0. Those are our defaults. Then we'll do def init. And we're going to take in, again, we need to take in first the things we need for employees. So that's going to be name and EMP number. Then we also need to take in the shift number and the hourly pay for the actual production worker. Again, at this point, remember, like we'll need to go ahead and make those getters and setters first. We'll do def set shift number. The shift number should be between either 1 or 2. So we'll say if shift number in 1, 2. That's the list of 1 or 2. So if it's 1 or 2, we'll do self dot shift number equals shift number they gave us. And then down here, we'll do hourly pay. So we'll do def set hourly pay. And we'll do this here, and we'll do hourly pay here. Then we can say if hourly pay is greater than 0. Then we can say self.hourly pay equals hourly pay, just like that. All right, so now that we have those, we need to do our getters again. So we'll just grab these two here again, bring those down below. And we'll do get shift number. And we'll do get hourly pay as well. And we'll change these out for shift number here. And we'll change that out for hourly pay just like that. And now we have our getters and our setters. Now, we need to actually initialize this. So what we can do is we come here, and we'll do employee dot init, this one right here. And then from that, we're going to do the name, and we'll do the EMP number as well, just like that. That's making the employee. Then we'll do self dot set shift number with the shift number you gave us, and then self dot set employee, or not employee number, set hourly pay for the hourly pay, just like that. Now we need our string again, so we'll do def str, and we'll do return the names. We'll grab this up here as a basis here. And we'll return name, employee number, and then we can also add on there the shift number, as well as the hourly pay, just like that. And then we can do dot format. We have our name, employee number. Now notice here, we don't actually have access to these right now because they're in the parent class. So what we need to do is we need to do employee dot get name self. This is where you pass self because you're saying, hey, from myself, get the name from the previous one. And then here we're going to do the same thing. We're going to do employee dot get employee number of self. Then we're going to do self dot underscore shift number. And then we're going to do self dot underscore hourly pay, just like that. So this right here says we're going to the parent class to find this. We're going to the parent class to find that instead. And then we have these two locally, just like that. All right, so now that we have that, keep in mind that what we've just done is we've overridden the string method of the employee with this one. And now we have all of our setters, we have all of our getters, and everything is good to go for us to actually use it. So we're going to clean that up a little bit. And then what we're going to do down here is we're going to say name equals input employee name. Then we're going to say while true, like that. We're going to say try to get the ID. So we'll say ID int input employee ID. We'll say accept. We'll say print invalid ID chosen. And then if the ID is correct, we'll do break, just like that. And then we'll copy this process a few times here for all the different ones. So we'll do ID, we'll do the shift number, and then we'll do the hourly pay. So we'll change this out for shift number. So we'll say employee shift number, be between 1 or 2. And then at that point, we'll do something along the lines of hourly pay. And then that's going to be employee hourly pay, just like that. And then we'll say invalid shift number and invalid hourly pay here as well. All right, so now that we have all those, we can then do P equals production worker with the name, ID, shift number, and hourly pay. And then if I print P like that, we'll see the actual worker. So if we come down here, we'll say employee name is Dakota, and ID is 1, shift number is 2, hourly pay is 10, and now we get this issue. So what happened here? So if you notice that issue, what happened is, remember when we're working in the actual subclass, we need to pass self to the superclass to tell who we're talking about. So we need to do self, comma, name like that. Okay? So if I run this again now with that same information, we'll say Dakota, 1, 2, I guess it was 2, 2, and 10, and now it works. So again, there's various ways you can actually go about actually interacting with the actual superclass. One way to do it is just do employee dot and then pass self. There's other ways as well, but I'll let you guys look into those for yourself as well. All right, so last problem I want you guys to do for this chapter is I want you to take what we just did, and instead of extending it with a production worker, I want you to extend it as a shift supervisor. The shift supervisor will have the same stuff an employee does, but it will also have an annual salary and an annual production bonus. So what I want you to do is I want you to go ahead and do that, and then I want you to go ahead and demonstrate that by writing a program that uses it. So go ahead and pause the video, try it on your own, and then if everything works fine, great. Otherwise, again, come back, we'll go over it, and we'll talk through it. All right, did you give that a shot on your own? So let's go over it. So what we're going to first do, because this problem extends the same thing, we're just going to take everything here, and we're going to go into our new file, and we're going to paste it in. Okay, so we have everything the exact same. Now what we're going to do, because employee is not going to change one bit, we're going to change this production worker to a shift supervisor. So we'll say shift supervisor. So we're going to just edit this class. So we'll say shift supervisor instead of a shift number. Now they have an annual salary. Just like that. Get rid of this guy. Just like that, we have our annual salary. Then we're going to have our production bonus as well. just like that. And we have that. So now we have our name, EMP number. We need to change this out for annual salary here. And then we need to change this out for production bonus here. So you'll see a lot of this stuff is going to stay the same. It's just templating, so it's the exact same. So now instead of an annual salary, we'll have that there. We'll have production bonus here. Instead of saying set shift number, we'll say set annual salary. We'll make a new setter for that. And we'll set one for production bonus as well, just like that. Now what we need to do is we need to come down here and change out shift number for the annual salary, production bonus for, well, production bonus. And we'll say shift number here is now salary. And then here we'll have our production bonus, like that. Now we need to change these actual setters as well. So we'll say set annual salary, say set production bonus. Oop, did I change the right one? Yes, I did. Production bonus there. This will now take a annual salary. This will now take a production bonus. Just change out those for all of those. Annual salary be like this. Now again, the annual salary will have a similar check to the production bonus, we're just making sure it's greater than 0. And then we'll change the annual salary out for here and the production bonus down here for hourly rates. So we're just swapping things around at this point. That's all we're doing. Now that we have those, we can then go ahead and change set this right here. So we'll now do a get annual salary. We'll do a get production bonus. And then we'll change the shift number out for annual salary again and production bonus for production bonus. All right, once we've done that though, everything again stays roughly the same. Now instead of coming down here to shift number, we have salary. And instead of hourly pay, we have bonus. And we say employee salary. And we say, instead down here, we say employee bonus. All right, and then we say invalid salary. And then down here, we can say invalid bonus. Okay. Now, again, we're not making a production worker, we're making a shift supervisor now. So we'll come down here and replace out that. We'll say this is salary now, and this is bonus. All right, so now if we run this now, we'll say now the employee name is me again with the ID of 1. The salary, let's say, is 50,000. And then the bonus is 10,000. And you'll see all that information pops right back out. So again, what we've done is when you're working with classes, the most effective thing to do is to reuse old classes and change them to your needs. So everything here works correctly. We've just made another subclass that extends employee, creates the employee initialization first, then we override the string, and we have everything set up correctly. So again, in this chapter, what we've covered so far is procedural versus object-oriented, classes and instances, class definitions, including the self parameter, data attributes and methods, the init and string functions, hiding attributes outside from outside code, storing classes and modules, designing classes, inheritance, and polymorphism. So again, if you have any questions, go back, rewatch this video, read the chapter, look over the notes as well. And again, if you have any questions, feel free to contact me as well. And I will see you guys next time.